Okay, so we're going to start a new unit today. And it involves some graphing and quite a bit of algebra, solving equations. Okay. And it's just a, like last year, you guys solved equations and then we did some problem solving where you set up an equation and you solve to find the solution. This is a different type of problem solving that we can use algebra where we actually use two equations, okay, instead of one. But just some terminology to start with. A linear equation is something that you guys have been solving for a long time now. So it's an algebraic equation in which the highest degree, and I'll define that in a second, it's not angles, the highest degree of the variable being solved for is 1. And the degree of the variable, okay, the degree of a variable represents if we were to write the variable with an exponent. So examples. If you have a variable which is just x, okay, how could you, what's the exponent that we would put here? We just normally don't write it. 1. So therefore, this would be degree 1. That's all that means. If I gave you one like this, x to the 4th, we would call it degree 4. And so on. You guys have been solving equations that have degree 1. So for example, if I said 2x plus 5 equals -7, that's a linear equation because if we look at the variable and write this with an exponent, it would be 1. So we just, it's degree 1. These are all the exponents you guys have been solving. Did I say exponents? These are all the equations you've been solving for a long time. We just never named them. Okay, but that's a linear equation. There's equations. You don't have to write this. Like for example, this is an equation of degree 2. Why? Because it's got a 2 attached to an exponent of 2 attached to the variable. What would be the answer to this one? 7, because 7 squared is 49. Okay? There's actually another answer that works too. Any idea? -7, because -7 times -7 is 49. Okay, so this is an equation of degree 2. Next year, we're going to start solving these things more and more. Okay, but for now, we're sticking with linear equations. We can have equations with more than one variable. Okay, so this we would call a linear equation because the exponents attached to the variables are each one. Okay. So we would say that this is a linear equation in two variables. It's linear because all the exponents attached to the variables are one, and there's two variables. This one, well, all the exponents attached to the variables are one again, so it'd be linear, but this time it would be in three variables. What we're going to focus on in this unit is linear equations in two variables. Okay? And we're going to focus on how to solve pairs of them. So I'm going to give you two equations that have x and y in, and we're going to figure out what x and y are. We're going to solve for x and y. When we have more than one equation or a pair of equations in two variables, we call this a system of equations. In two variables. So here's an example. X plus y equals 7. 2x plus 2y equals 14. Can you think of the variables x and y that would work in both of those equations? What numbers would work in both? What numbers for x and y would work in both equations? Any idea? Give me a pair of numbers that adds that. Okay, so if I said this was 3, I'll write that down. Is 2 times 3 plus 2 times 4, 14? No. 2 times 3 is 6. 2 times 4 is 8. 6 plus 8 is 14. So therefore, 3x is 3, y is 4 would be a solution to this system. Okay? There's actually, in this system specifically, there's many solutions that work. Okay? 5 and 2 would work. So the solution to a system of linear equations in two variables is those values for x and y that when substituted into both equations make true equations. A true equation is when the left side equals the right side. Left side equals right side. So like 4 and 3 is a solution because when I substitute 4 and 3 in here, I get a true equation, 7 equals 7. When I substitute 4 and 3 in here and evaluate this, I get another true equation, 14 equals 14. That's all. Okay? You don't have to memorize these terms. I just want you to be familiar with when I talk about a linear equation, when I talk about a system of equations. Okay? You should be familiar with what I'm talking about. One of the things that we're ultimately going to do with these is solve problems, solve actual problems. And that's what we did with equations last year when we solved them. Okay? So just to sort of start the problem solving process, we're going to practice setting, we're going to be given a problem, we're going to set up a system, and then we're going to be given a possible answer and we have to check and see if it works. Okay? So here's an example. A school district has buses that carry 12 passengers and buses that carry 24 passengers. The total passenger capacity for all the buses is 780 students, and there's 20 more small buses than large buses. Okay. Well, how many unknowns do we have here? 2. We don't know how many small buses there are. We don't know how many large buses there are. So, if these are the unknowns, let's call them X and Y. We don't know what they are. So, we need to write 2 equations in order to help us figure out what X and Y are. And you can see the 2 equations, or you can see the 2 equations, or you get the 2 equations from the problem. So we are told small buses carry 12, large carry 24. And the total capacity is 780. I can make an equation out of that. Okay? If there were 5 small buses, how would you find how many passengers on 5 buses? If each one carries 12.
12.
Sorry?
12 times 5.
12 times 5. If there were 10 small buses, how would you find how many passengers? 12 times 10. If there were 3 small buses and each one has 12, 12 times 3. If there were X small buses and each one has 12, X times 12 or 12X. So that's how many passengers on the small buses total. What would be an expression for the total number of passengers on the large buses? 24Y. And when I add all those passengers together, the problem tells me that it is equal to, you got one equation. 12X plus 24Y equals 780. This tells me how I can write an equation for how I can write the second equation in the system. There are 20 more small than large. How would I make that into an equation? Yeah. X minus 20 equals Y. That works. Because there's more small buses, but if I take away 20, I'm going to get the number of large buses. So that would work. Another way you could do it. There's more small buses, right? So there's more X's. If I take the small buses minus the large buses, what does that equal? 20. Both of these are just as correct. I kind of like this one because I've got X, Y, X, Y, and it'll help me when I solve them. But this is absolutely fine. Okay? So we set up the system. And let's say that somebody did the math and they think that there's 35 small buses and 15 large buses. How could we determine if this is correct? Plug them in here. Does 12 times 35 plus 24 times 15 and notice I put a question mark over the equal sign because I'm not sure if it equals yet. Does that equal 780? Because that's what they're telling, that's what whoever solved the problem is telling us. So does 12 times 35 plus 12 times 15 equal 780? It does. Because when I calculate the left side, it equals the right side and makes a true equation. So that works. Does it work in the second equation? And I'm going to use this one. Does 35, the number of small buses, minus 15, does that equal 20? Yeah. So what we would write as our final answer, we would just simply write the word verified. It works. Okay. So all we're going to do with this lesson is we're going to be given a word problem. We're going to be asked to set up two equations, and then we're going to be given a potential solution, and we're going to be asked to check to see if it's right. So let's look at another example. I want to look at a couple more because there's all sorts of different problems that can be asked. So the more you practice it with it, the better you'll get at it. So we're asked to create a linear system to model this situation. The perimeter of a Nunavut flag is 16 feet. Its length is 2 feet longer than its width. What are my two unknowns? What are the two things I don't know in this question?
Length and width.
Length and width. Doesn't matter which one you call which. I'm just going to do that. Okay, so I got to make equations. This tells me the first equation. How do you find the perimeter? Well, obviously the flag is a rectangle, right? Not all flags are rectangles, but we'll assume this one is. Okay. How do you find the perimeter of a rectangle? That's area, if you're saying length times width. That's all I'm hearing is, hi. Oh, you got a burger. Look at you. Anybody want to answer this question instead of staring at Ella and her burger? How do you find the perimeter of a rectangle? Yeah, a little louder. Just like push it, like dig it into the ground when you push it so it makes a block. That's it. That a girl. And then we got no shoes, Lucy. Right. Oh, I'm recording all this. Anyway, I'm still asking for the perimeter of a rectangle. Yeah. You can add the length and width and times 2. Or there's 2 lengths in a rectangle, right? There's 2 widths, so add them together. So 2 lengths plus 2 widths equals the perimeter of 16. How would I convert that one into an equation? The length is 2 feet longer than the width. Try and turn it into a subtraction one. Which one's bigger, X or Y, the length or the width? X. By how much? 2. So how do you write it? X minus Y equals 2. Bigger one minus the smaller one equals the difference. For B, we're given a potential solution. We have to check and see if it's correct. So length is 5, width is 3. Does that work in both these equations? Does 2 times 5 plus 2 times 3 equal 16? Yeah. 2 times 5 is 10, 2 times 3 is 16, 16 equals 16, we're all good. This one's even easier. Does 5 minus 3 equal 2? Yeah. So that works. So it works in both equations, so we are verified. It is the right solution. Try one more. So a school in Calgary raised $195 by collecting 3,000 items from recycling. The school received 5 cents for each pop can, 20 cents for each plastic bottle. So using all that, we're asked to set up a system. Again, start with your X and Y. What are our 2 unknowns here? Right. Cans. And bottles. Well, if you look at you'll be able to figure out the 2 equations from the information in the question. That tells me 1 equation. The total number of items was 3,000. How would I convert that into an equation? Don't overthink, it's really easy. X plus Y equals 3,000. The next one's a little bit more challenging. We get 5 cents for each pop can. We get 20 cents for each bottle. And when I add up those amounts, I get $195. What's an expression for the total amount you get from the cans? 5 times X. What's an expression for the total amount that you get from the bottles? 20Y. And when I add those total amounts up, I get 195. But there's something wrong. This is almost right. But you've got to look at the question carefully to see that we have to actually change one of the numbers. This represents 5 cents. This represents 20 cents. This represents dollars. We can't have cents and dollars. We have to convert them all to cents or convert them all to dollars. I'm going to convert this to dollars. How do you convert $195 to figure out how many cents that is? Divide times by 100, right? Because like $2 is 200 cents. $5 is 500 cents. I keep times them by 100. So I have to times this by 100. And when I do, I get this. So that's the challenging part of making that equation. Okay. I am told the potential solution. 2,700 pop cans, 300 plastic bottles. I need to check and see, is that a correct solution? In other words, does it work in both equations? Well, first one's pretty straightforward, but does 2,700 plus 300 equal 3,000? Yeah. That's good. Then I have to check and see if it works in the second equation. Does 5 times 2,700 plus 20 times 300 equal 19,500? Probably a safe bet that it will, but of course you do need to confirm on your calculator. Okay. When you multiply these two and add them together, you will get 19,500, which does equal the other side. So that means it works. So we are verified. Okay. I'm not going to do the last example. Okay. This is what I want you to be familiar with now. Okay. So the next step is going to be, well, we set up the system. The solution was given to us. How do we actually find the solution? And there's different ways we can do it. One is with graphing, and the other is with using algebra a couple of different ways. And that's basically the rest of the unit. Okay.